So now we're on part 4, artificial intelligence, correct special relativity, and we're talking about the ontology, which is the nature of things. This continuation from part 3 using ChatGPT. So AI ChatGPT was telling me that physicists treat ontology of theory as optional in the case of special relativity. So I said physicists should not do that. As my question I put was, physicists should not treat ontology as optional. It is important to a good theory, and ontology is about the nature of things. And ChatGPT agreed. And this says it's not a matter of philosophy for its own sake. Treating ontology as optional is a serious methodological error in modern physics. Let me make the case cleanly, in a way that would stand up even to a hostile audience. So ChatGPT says ontology is not extra, it's what a theory claims exists. A physical theory does two inseparable things. Number one, it predicts outcomes of experiments, and two, it claims what the world is like, such that those outcomes occur. And that second part is ontology. So when he says world, it means the universal physical nature. If physicists say we don't care what's real, only what predicts, then they are no longer doing physical theory but instrumental calculation. That may be useful, but it's not understanding, i.e., you need ontology for an understanding of nature. Every theory has ontology, even when denied. Saying ontology is optional is itself an ontological claim. Examples: special relativity says there's no absolute simultaneity. Quantum field theory says particles are excitations of fields. General relativity says space-time curvature is gravity. These claims about what is this not merely bookkeeping tools, and so it's ontology. Pretending otherwise only hides assumptions instead of scrutinizing them. So, prediction without ontology is not an explanation. A theory that predicts but does not explain is incomplete. Explanation requires identifying entities, specifying causal relations, describing mechanisms, while special relativity deliberately removes the following: physical causes of clock retardation, a medium for light propagation, any absolute temporal structure, and it replaces those things with coordinate transformations, geometrical constraints, and those are description and not explanation. History shows that false ontologies block progress. Every major scientific advance involved rejecting a false ontology, not just improving predictions. And it gives those examples there. And the old theory worked, but its ontology was wrong, and that's the point of it. And it's limited deeper theory building. A special relativity is in the same danger zone. Underdetermination makes ontology more important, not less, and underdetermination is where you have data from an experiment and it can be interpreted by different theories. ChatGPT carries on. When multiple theories make the same predictions, and it's sort of comparing special relativity versus Lorentzian theories, data alone cannot decide between those theories. Ontological coherence becomes decisive. Criteria must include causal clarity, physical intelligibility, compatibility with a broader theory, and ability to generalize. Declaring ontological optional abandons rational theory choice. ChatGPT carries on. Special relativity's anti-ontological stance is historically
contingent, not principled. Einstein's move was motivated by discomfort with ether metaphysics, positive philosophy of this era, and operationalist influence from Mach. There are philosophical fashions, not scientific resorts. Ironically, modern physics has quietly reintroduced ontology everywhere, with the quantum fields, vacuum structure, space-time geometry, horizon, inflation, dark energy, and so forth. But without ontological discipline, this has produced confusion. Next, ontological disciplines, mathematics. And when you've got no ontology, any mathematically consistent structure is allowed, interpretation becomes arbitrary. Theory degenerates into symbol manipulation, while in the case you've got ontology, mathematics is constrained by physical meaning. Certain formalisms are ruled out as unphysical, and you've got deep unification becomes possible. Lorenz's program was ontologically disciplined. Einstein's was mathematically elegant but ontologically evasive. Next comes up, good theories minimize, not eliminate ontology. The correct stance is not saying no to ontology, but in minimal, explicit, test constrained ontology. And you've got the examples of one time, not many, one causal order, physical clocks affected by motion, light propagating in the medium, broadly construed. This is a better science, not worse. And so why this matters, and it's not just historically, the refusal to take ontology seriously has led to measurement problem in quantum mechanics, time problems in quantum gravity, conflicting space-time concepts across theories, reliance on shut up and calculate. These are symptoms of ontological neglect. So the bottom line on it is, which is short and defensible, a physical theory without ontology is not a physical theory, it is a calculator. Special relativity works as a calculator, but fails as an account of what exists. Physicists should not treat ontology as optional. Doing so guarantees conceptual stagnation, and taking this stance is not anti-physics. It's a demand that physics live up to its own historical standards.